Hello, I welcome you again to this lecture. I welcome you to my channel where we discuss issues in physical science. I have someone who sent this question to me. I've put the PDF here. I hope you can see it in the video. We are told we are actually given a particle which is projected with initial velocity u at an angle of theta to the horizontal. And it is said that the particle reaches a maximum height of 40 meters per second, and then it has a range of 160 meters. And then we are asked to find the initial velocity u, and then also to find the angle theta. Now, of course, we want to start this by analyzing what are some of the things that are known to us. For example, if I say that I am beginning with vertical motion. Now, I always want students to remember that if a question comes and we talk about maximum height, because this is h max, whenever we talk about maximum height, at maximum height, the vertical component of velocity is always equal to 0. And so this implies that vertically, I am going to be knowing around three things. First of all, Vy is equal to 0. The number 2, we always know that our initial velocity is u sine of theta. The number 3, we always know that acceleration is equal to, but in this case, acceleration is 10. So this is minus 10. Okay, it's always equal to g. And then now we are asked to find u, theta, and so on and so forth. But what we have here, of course, we also do not know what time. Actually, we know the maximum height. In other words, we know that y is 40, but we also don't know the time it takes to reach h max. This one is not known. Now, I want us to use v, u, a, and y, first of all, in an equation, so that we can get something for uy. And if you look at v, u, a, and y, actually, there is an equation which is more appealing. Which equation is that? Someone think about it very fast. That is the third equation, from v squared is equal to u squared plus 2as. So from this, my vy, it is a 0. Then my u, okay, let me keep it as u for now, as uy squared. I'll substitute later. This will be minus 2 into 10, and then with the distance, which is 40. So you can clearly see that our uy is going to be equal to the under root of 800. And we still know that the under root of 800 is the same as from your studies. This is 20 root of 2. Now, ladies and gentlemen, remember uy is u sine theta. So this simply implies that my u sine of theta is equal to 20 root 2. Allow me call this equation number 1. Now, having uy, I can come and obtain the time taken to reach to maximum height. So I can come and say from another equation that is going to be v is equal to u plus at. Now I know that I have obtained v. Actually, I have v is 0. I've obtained u. I know acceleration is 10, so I can find the t. So I'll now come, I say my v. What is v? V is 0 because of maximum height. Then what is our u? Our u, our initial velocity, you saw it as 20 root 2. This is 20 root 2. Then this is minus because of the acceleration. This is going to be 10 of t. So I hope you guys can see it clear that our time t, after dividing, shall have time t as equal to 2 root of 2 in seconds. So that is our time, first of all. And then we have the time. That's one of the things they ask. Time taken to reach maximum height, though. I think I forgot to include it here. You'll see it in the question that I've posted, the PDF. Now we have also find u and theta, u and theta. So for now, to find those, I'm going to first go for horizontal motion a little bit. So let's come to horizontal motion. Now still ask yourself a question. What do I always know horizontally? Horizontally, I know that my initial velocity ux is going to be equal to u cos of theta. Horizontally, I still always know that acceleration is equal to 0. And now at the point of maximum height, at maximum height, we can see, because the projectile is symmetrical, so at maximum height, this will be divided into, say that this one is equal to 80 meters, and this is 80 meters also. That means that at the point of maximum height, we know that our x is going to be equal to 80 meters. Yes, and so now I already know the time because the time is the same. So time is equal to 2 root 2. Yes, so this is where we are. And I think we have an equation which relates all of these, if I'm not mistaken. I think we know that from s is equal to ut plus a half 80 squared, all these will be included. My s is 80. This should be equal to. Now, I hope you see, since the acceleration is 0, all this element will come to 0. The moment you plug in 0 there, this will become 0. So you're left with ux. So allow me for now to first call it ux just in times t. The time is 2 root 2. So you can get our ux as equal to 80 out of 2 root 2, which by the way proves to be the same as 40 out of root 2. Now ux, we have just seen that ux is u cos 30. It's not 30, sorry, it's theta. It's theta. Such that now this implies that our u cos of theta will be actually equal to 40 out of root 2. And I can gladly call this equation number 2. I hope you see I have two equations. I have 1 and 2. So I can easily come and say equation 1 out of equation 2. This will be u sine theta out of u cos theta is equal to, now the sine, this side you have 20 root 2 out of 40 out of root 2. So the u cancels, you obtain tan of theta as equal to, now I think we can see that this is going to be equal to 1. And of course the tan inverse of 1, theta will be equal to 45 degrees. So we have your angle theta. Now having theta, we can use either this equation or this one to obtain u. You can choose any, but I'll choose first equation. So from u sine theta is equal to 20 root 2. This will be u sine 45 is equal to 20 root 2. But you know sine 45 is 1 over root 2. So this is 1 u over root 2 is equal to 20 root 2 times root 2 both sides. We shall get our initial velocity u as this will be 40 meters per second. And I think this is what was required. We have been able to get our time to maximum height. We have got our angle of projection, and we have got our initial velocity. Thank you for watching, and thank you for asking the question. Everyone who has a question, please go ahead and ask the question. I'll gladly help you with the question. I want to wish you a nice day.